Hello guys, my name is Bob. In this video, I'm going to show you the solution to the integration problem e to the power x sine x. But before I do so, if you guys like this solution, help me press the like button so that this video can be ranked at the top of the search page to be shown to more people who are finding this problem. And also, if you guys liked the integration problems, do consider to subscribe to this channel. Let me start off by solving this problem using the integration by parts technique. So what does the integration by part technique tells us? It tells us that this particular function can be split into two terms. One I define it as u and the other one I define it as dv. So this is equivalent to uv minus away the integral of v du. So what does dv means? dv means that the differentiation of v, well, du is derived from the differentiation of u. And if I want to find u from du, what I will do is I will integrate du. The next thing what I will do is I will define from this particular function what is my u and what is my dv based on the integration by parts. So I let u to be sine x and dv to be e to the power x dx. I differentiate u with respect to x in order to find my du. So this gives us cosine x, in which du is equals to cosine x dx. V is basically the integral of dv, which is the integral of e to the power x dx is equals to e to the power x. Of course plus c, but we put it there. Okay, so once we are able to find out my u, v, dv, and du, I can use the integration by parts equation to define the next step. So the next step will be as follows. The integral of e to the power x sine x dx, where u is equal to sine x and dv is equal to e to the power x, is equivalent to u, which is sine x, times v, which is e to the power x. Of course, we have a plus c behind. And then minus away the integral of v, which is e to the power x, du is cosine x dx. So this plus c you can actually bring over behind. So we get sine x times e to the power x, subtracting away the integral of e to the power x cosine x dx plus c. The next step, we work out the integral of e to the power x cosine x by using the integration by parts technique again. This time around, we let u be equals to cosine x, and then we let dv be equals to e to the power x dx. We differentiate u with respect to x to find what is my du. So this gives us negative sine x, in which my du is equals to negative sine x dx. To find v, we simply integrate dv, which is equals to the integral of e to the power x dx, which is just e to the power x plus c. Yet again, once we find what is my u, v, du, and dv, I can use the integration by parts formula to move on to the next step. So this is equals to e to the power x times sine x. So I copy the first term, and then what I will do is I will evaluate the integral using the integration by parts. So I will get the following. My u right now is cosine x. My v is e to the power of x, subtracting away the integral of v, which is in this case e to the power x. And then my du is negative sine x dx. Okay, so what I will do is I will open up the square bracket. I will get the following. So we have the third term, we have minus, minus, and minus. So this gives us minus the integral of e to the power x sine x dx. Okay, so the next step, what you have realized is that this particular integral is the same as our question. So what we can do is we can add both sides by the integral of e to the power x sine x. What we will get is we will get 2 integral of e to the power x sine x dx equivalent to e to the power x bracket sine x minus cosine x. And last but not least, to find out what is my integral of e to the power x sine x, we just simply divide both sides by 2. We will get integral of e to the power x sine x dx is equals to e to the power x sine x minus cosine x over 2. So if you guys do like this solution, help me press the like button to rank this video on top of the search page, and do consider to subscribe if you are an integration problems geek. My name is Walt. Thank you guys for watching. I will see you in the next video. Goodbye guys.